Hi, I am Radhakrishnan, MSc MPhil, Assistant Professor in Dept.of Electronics, GVN College, Kovilpatti. Today we are discussing about the 8051 microcontroller. In between the 8051 microcontroller, already we know about the 8085 microprocessor. It is also a 40-pin. It is also a 8-bit microprocessor. Today we are discussing about the 8051 microcontroller. Simple introduction about the 8051 microcontroller. It is an 8-bit microcontroller with 8-bit data bus and a 16-bit address bus. It is has 34 general purpose registers in total. It is only available of ALU. It is called as arithmetic logic unit. It performs the 8-bit operation at a time. It consists of two 16-bit counters and timers and 3 internal interrupts. One is the serial interrupt, second one is 2 external interrupts. It consists of 4 8-bit I/O ports. Next we will discuss about the pin diagram of 8051. In 8085 also 40 pins. In the 8051 also 40 pin. In the 40 pins, the 2 pins will be power supply. Comparative to 8085, 8051 pin diagram is very simple for us. The 20th pin is ground, 40th pin is plus VCC. About that 40 pins, nearly 4 ports. That means each port consists of 8 pins. 32 pin will be port. The ports are available in the P0, P1, P2, P3. In that 4 ports, the P0, P2 and the P3 is for doing some other functions. That is called as, for example, P0 port is used for address and data buses, P2 used for address buses, then P1 is used for only I/O port. Especially the port 3 used for the multifunctional bits, multifunctional pins. For example, in the port 3 we are used as the RXT pin, TXT pin, INT0, INT1, T0, T1, write bar, read bar, and also we are used for the P3 port 3. Next we have consist of 2 oscillators, that is called as XTAL1, XTAL2. It is the crystal oscillators. Next pin is ALE, it is for address latch enable. Next one is reset. That is all the 40 pins of 8051. Next we are discuss about the architecture of 8051. It is very easily work comparing to the 8085. The 8085 architecture is very complicated, but 8051 architecture is very simplest one. Same like as the same concept of blocks used in the 8085 8051 is ALU, stack pointer, program counter, DTPR, EPROM, EPROM. They are same as the 8085 and the 8051. Here only difference is the PSW. The difference PSW. In the 8085 it is used as flag. That means flip-flops in 8-bit. Now we discuss about the architecture of 8051. It has here 2 registers, that is called as A register and B register. It is used for storing the data and inputs, some like as. Next, temporal register, it can be temporarily store the data. Next we discuss about the ALU, that is called as arithmetic logic unit. It can be perform the arithmetic and logical unit functions of, that is include the accumulator, temporal register, arithmetic logic units. The block will be indicated. ALU consists of accumulator, temporary registers. So, the temporary register used to hold the data during an arithmetic and logic operations. That will be stored temporarily holding the data in the arithmetic logic operations. The result is stored in the accumulator register. Already we have discussed about the 8085. It is also called as accumulator is an A register. In 8085 it is also called as A register. Here same like as the accumulator register is accumulator or A register. Act as an operand register in case of some instruction. It will be acting. Any one of the function will be doing, that is the final result is stored in the accumulator. Next one is program status word. In this program status word, in 8085 it is called as flag. That means flip-flops. It also consists of 8-bit. It is 8-bit. It can be display which carry flag will be available, which flag is affecting. It is called as program status word. Into the 8-bit 0 to 8. The 0 is carry flag, AC is auxiliary carry flag, FO is overflow flag. Next one is RS1, RS0 means register selection, register bank selection bit, RS1 and RS0, overflow flag. The dotted symbol is used for the future use. The P is an parity flag. The below table is represent the register bank selection. In the register bank RS1, RS0, that value will be 0, 0. We can select in the registered bank 0. Then was 0, 1. 0, 1 means we can select the registered bank value is 1. Then 1, 0, we selecting the registered bank value is 2. Then the RS1, RS0 is selected both of 1. We have selected the registered bank 3. It is also displayed in the architecture diagram. That will be PSW, that is called as program status flag. Next we discuss about the stack pointer. Stack pointer is nothing but is a 8-bit register. It is a 8-bit register. It is used for increment or decrement the values. Before stack using, the instruction is push and call. We are using the instruction for the increment the stack pointer. We are using the push or call instruction. We have increment the stack operation, the 8-bit content of the operation stack after increment SP register by 1. The value of the stack pointer register is incremented by 1 using the stack pointer instruction push or call. Next we discuss about the data pointer. Data pointer is a 16-bit register. It contains both split into two 8-bit registers, that is called as DPH and DPL. That means data pointer higher, data pointer lower. It is called as data pointer higher byte and data pointer lower byte. Suppose we need the only 8-bit register means we can split it into two, DPH and DPL. Suppose we need a 16-bit means we are pairing with the DPH and DPL. It is the external data RAM address. It can be, already we say, it is accessed as two 8-bit specified effort. It can be allotted two address specified ones for 2 bytes. It needs the 2 bytes. It is called as DPH and DPL. In the architecture diagram, we consider the port. The port means it is used for the input and output ports. It is used for the latches and drives. The latches and drives is used for matching the I/O values to the. It is allotted upon the special function register. The port 0 to port 3 is used for only the I/O ports, input and output ports. We are using connecting the some devices like as interfacing traffic light controller, stepper motor, ABART converter, that is used for the port address only. Next we discuss about the serial data buffer. Normally the buffer means it is the store some data. It can be stored in some data. In the serial data buffer, internally contains two independent registers. There is the independent register that is called as PISO and SIPO. That means PISO means parallel in serial out register. We are giving the input in parallel, the output will be in serial formation. Next buffer is serial in parallel out, that is called as SIPO. We are giving the input in serial mode, getting the output in the parallel mode. Next one is timer register. Already we discussed about the introduction. We are having the two timers and counters. It is also a 16-bit register. In the 16-bit register, timer can be measured as two values, that is lower and higher. That is lower and higher. The higher will be called as upper byte. The upper means that value is TL0 and TH0. TL0 means the timing register value will be 0. TH0 is the timing register 0. Lower value and higher value, it will be upper byte values. Next one is TL1 and TH1. It represents the lower byte and higher byte of the timing register 1. It is a register by timing register 1, shortly called as T0 and T1. We can split it into TL0, TH0, TL1, TH1 because it is a 16-bit register. Next one is control register. It is a special function register. It consists of IP, IE, T-mode, T-con, S-con, P-con and status for information, timer and counter in the serial port. The IP means it is the interrupt priority. IE means interrupt enable. T-mode is timer mode. Next one is timer control, serial control, power control, the content control the modes, and also timer counters and serial interrupt is available on the control register. All of the registers allotted in the special function register bank of 8051. The above register, that is IB, IE, T-mode, T-con, S-con, P-con, timer counters and the serial port are, the space is allotted in the special function register black. In the architecture diagram, we can see there is special function, special purpose register. There is available places for IE, IP, T-con, P-con, S-con, T-mode and all of them. Next we discuss about the timing and control unit. The timing and control unit is used for the signal recovered and the signal receiving. We are giving the one control to the microcontroller. It can be recovered from the control system of bus or controlling the system bus. For example, we are giving one instruction, move x at DPTR, A. That mnemonics is move x DPTR, move x at DPTR, A. The meaning is the accumulator value will be moved to the DPTR, data pointer value. That have some amount of times, that have needed some amount of time. It will be internal operation of the circuit. So that the command will be passed to the controlling circuit, that will be indicated to the system bus, that convert the signal to the particular mnemonics to assembler directives. It converted into opcode. That is the purpose for timing and the control unit. Next we are discuss about the oscillator. Already we have discussed about the pin diagram. We are having two oscillators, that is called as XTAL1 and XTAL0. That is the oscillator used for generate the basic timing clock signal for operation of the crystal. It is a crystal oscillator. Next one is instruction register. We need so many instructions: move instruction, add instruction, subtraction, div, multiplication, logical instruction, boolean instruction, arithmetic instruction we are having in the instruction. That the register decodes. The register will be decodes the opcode of an instruction. Particular instruction we are giving, that will be convert to the opcode to the that information given to timing and control unit. Already we are seeing about the timing and control unit. It also tries control signals recovered for controlling system bus. So here the instruction register will be gives information to the timing and control unit to necessary signal for the execution of the instruction. That is used for the instruction register. Next one is EPROM and the program address register. The EPROM already we know, it is a electrical programmable read-only memory. The blocks provide the mechanism of internally address it. It can be mechanism. Some values will be stored. It will be recovered from the. The important point is the EPROM is not available in all versions of 8051. 8051, more of the versions will have Intel 8051, Toshiba, so many versions available. In the EPROM is available, not available in all versions of 8051. It will be some available in the particular microcontrollers only. Next one is RAM and RAM address register. The RAM already we can know. RAM means random access memory. It can be 128 bytes of RAM and a mechanism address is internally. It's also the internal registers. Next one is special function register, that is called as register bank. We have discussed about the register bank in program status where already it will be RS1, RS0 is the register bank. This is a set of special function register. The set of function, it can be addressed the respective address. So it is called as the range is 80H to FFH. The range is address range is 80H to FFH. Finally, the interrupt serial port time machine control performs specific function under the control of timing and control unit. So all of them, the system can be all of them controlling using the timing and control unit. It is the special function register explanation. Thank you.